Hello everyone and welcome to Short Circuits. This is a project that I'm going to be working on. This is my Amiga 1000. I picked this guy up at a thrift store for about $200 without really knowing what I was getting myself into. It was literally just this box, which does turn on, which is a bonus, and it looks for a disc to boot, which is really great. Downside is the Amiga requires several things that I don't have. One of which is what's called a Kickstart disk, which is the BIOS that operate the system. It doesn't have a BIOS chip in it. The Amiga 1000 did not have one. It comes on a floppy disk, which I don't have. The second thing is anything to boot into after that. Once the BIOS are booted from the disk, you have to swap out to another disk, usually a workbench disk, which acted like a Windows, early version of Windows or similar. And so I don't have that. The second thing I don't have, which is kind of proprietary, is the keyboard. And the Amiga keyboard itself is nothing really special except for the fact it uses an RJ10 connector, which is a telephone handset connector to connect between the keyboard and the back of the Amiga. Now I was able to pick up a handset keyboard, or excuse me, a handset connector, which was great. But as you can see, there's no keyboard to go with it. So one of the big things, and one of the reasons I put together Short Circuit, is to chronicle the creation of a few things that will get this Amiga back up and running in our modern age of USB, PS2, and BIOS that don't come on floppy disks. I'm not going to go into the whole thing now because there's going to be a lot that goes between what you see here and what I'm hoping will become a fully functioning Amiga 1000 computer, which will make me absolutely happy. Hopefully we'll be able to go through this little journey together, and when we get to the other side, everything will work. And even if I'm not, and I know I'm definitely not the first person to go through all of these steps, even if I'm not, I'm hoping that I'll be able to at least help out a couple people who may be down the same road as I am. So let's go ahead and get started. Okay, so in order to start our project, the first thing we're going to need is this. This is an Elegoo. Basically, it's a Arduino Uno clone. So we're going to just unbox this little guy. And it says right here, if the seal on the bubble bag is damaged or peeled off, please reject and do not open package. And as far as I can tell, it is not. There's a little tear here, but that is not important. So I'm going to go ahead and do this and hopefully not slice myself open here on cam. That's actually a lot harder than I thought. So let me do it like so and see if that'll work. Boop. There it is. So this is the Elegoo Super Starter Pack, as you can see right there on the front. And it comes in a nice little box, which I was surprised at, although it does show that on Amazon where I got this. I didn't see it until after I bought it. So it does come in its own little box, so a nice little storage case. And it comes with a lot of stuff that I actually, well, that's very loud, a lot of stuff that I actually don't need. So there's a huge list of items right there on top. It tells you all the things you're going to need or going to get out of it. I only need a couple of things. I need the board, I need the cables, there's a breadboard in here somewhere, I think it's that one there. And I'm probably going to need, and I can't see it from this angle, I believe it's that. Is that the right one? Yeah, LCD screen. So those are the only things I'm going to need, as far as I can tell, for my portion of this. So there's going to be some parts and pieces that are not required. A little card here. Elegoo, thank you. You're welcome. Follow us on social media. I'm okay with that. I'm a happy customer, and I have a problem. So, a couple of things you can go for if you need to. Super Starter Kit, this will be helpful for me, as I've never used this before. This is a lot of tutorials and things like that that will teach me how to use this little guy. Hooray! That I'm not going to show much of, I don't think. Sorry about that. I got this board underneath for the purposes of keeping the metal of my case off of the metal of my project so I don't short anything out. So here in the corner, and again you guys are having trouble seeing this because I'm way down here. Here you go. So here in the corner is the Arduino come out in a nice little case, a daughter board for all sorts of fun stuff. And again, I'm only looking for a few things. I believe that is definitely probably a power cable as far as I can tell. Again, I've never used this, so I have no idea. I'm just looking for certain pieces. The rest of it, I don't really care about. Okay, I'm going to need these for the breadboard because those are all my connector wires. The nice little LCD screen, which came pre-soldered with the connector pins because they're very kind to do that. And what else are we looking at here? I might have to pull this closer. One moment. Aha, there's a breadboard down there. Okay. LEDs, lots of the microchips, all sorts of fun jazz that we can work with. So let me go ahead and just pull all this out, get it in order, and we'll see what we actually need. But for now, I know for a fact that like these parts right here are where we're going to start with, and then I'll get the rest of this out and take a quick look. Alright, so, for lack of a better option, that's about what we're looking at. And again, there's not a lot that I need. Most of the stuff is just going to be a pass-through, so I'm going to need some data. Now, I have a chicken and egg situation here when it comes to the Amiga, in that I don't have any of the input devices, and I don't have anything to run on it. So, in order to get things to run on it, I need input devices, and in order to get input devices, I need something to run on it. So, I don't have all of the project parts here. Some of them are still coming in. Those are going to take a while. So, while those come in, we're going to be taking a look at this stuff. I'm going to be doing some things with it and seeing if I can learn some stuff. But what I'm going to do is I'm just going to go ahead and figure out how all this works, how I can get information into the Uno and then back out again. I'm going to use the LCD screen for that. I think, just kind of to learn how everything works. So yeah, let's go ahead and get started with that. Alright, fast forward to a couple of days later, and you can see what I've put together here. I didn't actually have to go through too many tutorials to learn how the Arduino works. It runs on C++, which I'm semi-familiar with. It's not one of my favorite programming languages, but when I got back into it, it wasn't too hard to learn or relearn. I did have the LCD screen on here. Turns out it worked for some information, but it wasn't required because there's a serial interface. That's the blue cable there that goes to the USB port. It also provides power to the Arduino, which is currently off. On there you also see a crappy old Dell keyboard I got for like $3 at a thrift shop. And the purple cord is the PS2 port, which is then forcibly wired into the breadboard, which goes to the Arduino. I did get some code smashed together, and I say smashed because I literally spent about 3 days writing and rewriting code that I have never tested. Completely untested code. I have no idea if it'll work. It follows some information that I found in a hardware coding book for the Amiga 1000, which seems to have all the important information, clock speeds, responses, what's in charge of what, and for all intents and purposes, something should happen if this were to be connected to an Amiga. What that something is, I honestly have no idea. It's still to the point where I don't have the ability to boot the system up. But that has changed today. So what we're going to do is we're going to take a quick look at some more parts and pieces we have that have finally come in and what those mean to the project. So we'll take a look at that. Our next stage in the project is going to be making a floppy disk reader writer. The floppy drive on the Amiga, as far as I can tell, does work. I don't know. I don't have any disks that will boot up on it. I have nothing that will boot because I need the BIOS disk. And in order to make a BIOS disk, there are many different things you can do, but most of them either require an Amiga that works, or someone who has an Amiga that works and a bunch of double density disks. Since I don't have either of those things, I'm going to do this the hard way, and I'm going to do that with the Arduino Amiga floppy disk reader writer created by Robert Smith at robertsmithdev.co.uk if you want to take a look at what it is. And you can take a look at the project so far. That's a history of the project that he went through, all the little steps and everything he went through in order to make this work for himself. We're going to skip over that, and I'm going to go right over to the setup instructions. And I actually have all the parts we need. We need a PC floppy disk drive cable. Now it does say cut to remove the twist. I don't believe I have to cut mine, but we'll find out. We have an Arduino Uno read-only or a Pro Mini recommended. Luckily I have both. FTDI converter, which is a breakout board, 1 kilo ohm resistor, 1 breadboard optional, and then 5 volt power supply, and a possible 12 volt power supply required by some floppy drives, and we'll have to see if ours requires it. But then we have 2 wiring diagrams here, which explain how to put everything together in both the Uno and the Mini. I preferred using the Mini because the way he wrote his instructions suggests that the Mini is better. I won't say more stable, it uses the same code, but it's better, and if I'm going to be using the Uno for the keyboard, I need all the pins I can get. So as you can see, this takes up a lot of pins in the Uno, including a couple of pins that I myself would be using for something else. Plus, I don't really want to mix my code if I don't have to, and interrupts and all, a lot of complicated mess I'm really not versed in to make it work. But if we take a look, we can take a look at all the parts that we have as I have them laid out here. And here they are. So we're looking at both the Uno as well as the Mini. Both will work for this project. I would like to use the Mini, but when I ordered the Mini and the breakout board, I forgot to order pin headers. And so I have no way of connecting any of this together via my breadboard without causing a short somewhere. Problem I'll have to figure out a way to work around if I'm going to use that, unless I'm going to directly solder parts to it. I also have a cable here which I have not cut. I did actually zip tie it together so I could just plug it in, skip all the middle people, and then plug things directly into the cable itself. A lot of connector cables here, enough to do all the grounding and everything else, and 2 floppy drives which may or may not require 12 volt. Now I did take a look. I have one here, and it's an NEC FD1231H. That one I did take a look at the schematics because it has more serial numbers than this top one does, and it says it takes plus 5 volts. It does not state that it requires plus 12 volts. So we might get lucky, and even though it has the 12 volt pin on it, it may not be required. So what I'd like to do is I'd like to go ahead and figure out a way, hopefully, to get this Mini tied into this board and everything else all plugged in together, and see if we can get it working. At this point I stopped recording audio to concentrate on my work as there were a lot of pins to connect to the floppy drive. Skip ahead, and all the pins are finally into the drive and connected to the Uno. As I don't own any double density disks, I had to stick with what I had on hand, a 1.44 megabyte high density disk. Everything I read online said they should work if properly formatted. Unfortunately, the floppy drive doesn't seem to be responding to the Arduino, and I kept getting an error to check the pins. A couple tries later, and I decided it was time to move to the next stage, soldering. Since I was going to be soldering the cables to the Mini rather than the Uno, I decided to use that instead. After cutting the cables to a decent length, it was time to get the FTDI and Mini together. Unfortunately, the header connector was in the way. Trying to remove it, I found the copper lines were absorbing all of the heat from my soldering iron, and there was no way to remove the header. Luckily, the FTDI board came with a 6-pin header that I bent into shape and soldered to the Mini. The downside being that the pins of the header were also absorbing all the heat from my soldering iron, making it nearly impossible to solder even a single pin. Eventually I was able to get the first pin. The second pin was probably the best soldering I did on the entire project. The remaining pins became even more difficult to solder, and after creating a few solder bearings, I cleaned my solder off and decided to do the rest off camera. Next, I had to solder a jumper wire between the CTX on the FTDI and the VCC pin on the Mini. Again, I ran into the same heat problem as before, though double now as the amount of copper between the connections was twofold. Again, out of frustration, I stopped recording to get the wire soldered into place. After that, it was time for the main cable wires. I put a bit of solder into each connection point with the plan to reheat it and push the wire through. The first wire went in well, as did the second. Somewhere along the way, I ended up overheating the first wire and had to resolder as the solder joint melted through the PCB and fell out, leaving the wire loose. The fifth pin had to be connected to two wires on the floppy drive. It was shortly after soldering these in that I realized I'd forgotten to put the 1 kilo ohm resistor into pin 4. Doing the same thing I did before, I heated the solder and pushed the lead through, only afterwards realizing I should have shortened it. I tried to heat the solder and remove the rest of the lead, but it wouldn't budge, so I cut it off instead. After trimming the leads, I then soldered the resistor into place. After all the soldering was done, I had a lot of flux and possible burn marks left on the board. To prevent any shorts, I decided to clean the board off. I had to be gentle with cleaning as several times during the soldering process, several of the floppy cables snapped and had to be restripped and resoldered. The finished board, much cleaner. However, upon attempting to write my disk, I ran into the same issue as before, no floppy activity. To make sure I had all the power I needed, I plugged the drive directly into the power supply on my Pentium 4 machine and gave it another shot. And it works! Now time to write a Kickstart and workbench disk. They had a lot of failure to verify write errors, but I ignored them and tried it anyway. And on startup, the Amiga asked for the Kickstart disk. It took a few tries to read it, but it works. Then the workbench disk, and that boots up just fine. And there it is, a working Amiga 1000. Now the next stage is to attempt to get the custom keyboard interface to work, but that will have to wait until another video. For now, I'd like to go ahead and thank you all very much for joining me, 4KB Short, on this episode of Short Circuits, and I will hopefully see you next video.